So we're on Unit 5, Lesson 4. I'm doing things a little bit differently than I did in even my first two classes. And like if you really want the full lesson, every single thing on your note sheet answered in a way that you can understand, I'd recommend in the slides where I have the video from last year, which shows you right there, couple videos from last year. You can watch that on your own time if you want. Whatever we write in class on the note sheet is what I hold you accountable for. So even if it's just a little bit, that's just what I expect you to have. I don't necessarily expect you to have more unless you on your own time feel like doing that. The homeworks are like the assignments that are in Schoology. These are your notes, and I only hold you to what we do in class. Okay. So this one I asked you to try as your warm up. So we have a person makes $1,800 per month. About a third of that amount goes to her rent. What two numbers can you multiply to find out how much she has after paying her rent? Who thinks they have it? Question is, what two numbers can I multiply? Figure out how much she has after paying her rent. Zachary? Like times 3/4? Okay. Why 3/4? Okay. And why 2/3? Okay, so this actually is correct. And because how much does she have after paying her rent? $1,200. Now, I'm sure more of you were able to get this answer than what this question asked for, which was the two numbers, do I need to multiply? And you might be wondering, why 2/3? Well, the question didn't say what two numbers can I multiply and then subtract from the original, although that is probably what a lot of you would do. So like if you did 1,800 times 1/3, figure out how much she's paying for her rent, that's 600, right? And then to find out how much she has after paying her rent, you might have done 1,800 minus 600, which does give you the right answer for how much she has. But this is two steps, like two things you might have to put in your calculator versus one step. So again, why the 2/3? Well, if we're trying to figure out how much she has currently versus what she's spending, if I have, say, something split into thirds, and I take away a third of it, how much do I have left? 2/3. So if I multiply by what I'm keeping rather than what I'm spending, and the question is, how much does she have for paying her rent? That is just one thing I have to put in the calculator. I guess in your head, you are having to do the 1 minus 1/3, right? If you want to write this underneath it for where we got the 2/3 from, it's because we did 1 minus 1/3, which is 2/3. But I don't know, I feel like that's easier to do in your head than 1,800 minus 600. But that's like a matter of opinion, right? So if it's a real world problem and it's just asking you how much does she have after paying her rent, however way you get there, up to you. But for this unit, when we're talking about exponential functions focus on what we're multiplying by each time, right? Not like multiplying by something, then subtracting it, and then that's our answer. It's just we're multiplying by the same factor each time. Questions on that? Okay, so then this one, which I did ask you to try, but I mean, we'll see if anyone got it right. You're supposed to write an expression that only uses multiplication. Just keep in mind our exponential functions that we talked about Friday, that equation I gave you. And we even write it over here so that you have it. A times b to the x, or t rather. I kind of prefer using t so that you remember that the exponent is per time, right? In this, we are multiplying. We're not like subtracting necessarily, although you could write it a different way that allows for it. In exponential functions, we care about what we're multiplying by, where b is our common factor. That's why we are focusing on making expressions that just have multiplication in it. But this one, we want something equivalent to x reduced by 1/8 of x. Does anyone think they have that answer? Or something that's equivalent to that, but only has multiplication in it. All right, don't overthink it. Are these like terms? They are. So what's the coefficient if it's not written? 1. Now, I'm working with fractions. I mean, you could type in your calculator 1 minus 1/8. You don't necessarily have to convert it. But if I was having to subtract 1/8 from it, I might, instead of doing 1, do 8/8, because that is 1. But let's just show you. 1 minus 1/8 is this as a decimal, but this as a fraction. Okay, so almost all scientific calculators, graphing calculators have a decimal to fraction button. So 1 minus 1/8 is 7/8. And since these are like terms, I can subtract them. And then the x is still there. So this would be just multiplication, right? It's 7/8 times x. And it's equivalent to what we have. That one's a little harder, I think, because it takes out the real world aspect of it. But that was the answer, in case you were curious. Questions on that one? All right. Now, on the back of your notes, you have a spot to put your exponential, it says decay formula, but I'm going to give you one that works for both. So, side note, yes? Yes. We've been talking about exponential growth in the first 3 lessons. Now we're looking at exponential decay. So if you are familiar with hearing exponential, like in the real world, when they say like something's growing exponentially, that means it's growing at a really fast rate. But now decay, now it's decreasing at a really fast rate. We put it. But you have room on the back for exponential decay formulas, but it really is just exponential formula. There's 2 ways of writing it. So one way we talked about on Friday briefly, so it's this way. But here's another way that works. If you have, say, like a percent, then you might want to use this other one. If you're writing this down, you have space on the back where it's like exponential decay. We're going to talk about both of these setups, so right in the middle. All right, aside from the exponent, the one on the left is only using multiplication, right? So A in both of these is what in the situation? A stands for I don't know what I heard, but it didn't sound right. Take the thing we just talked about in the warm-up. We did 1800 times 2/3. What was that 1800 representing? Oh, we understand about it. So we need the initial value when we're doing these, because that would make a difference. If we're multiplying each time and changing what we currently have, it's important to know what we started with. So in both situations, identify your initial amount, put it in the A of your formula. Now, in the first 3 lessons, we only looked at situations where things were doubling each time. Make sure to pay attention, not playing games. We looked at things that were doubling each time, tripling each time. That's really it. That's all we talked about. If it says something like that, where you know what you're multiplying by each time, use this one. Because what does B stand for? Common factor. And what math do we do with factors? We multiply them. So whatever you are multiplying by each time to get to the next number is your common factor. In the situation from our warm-up, it would not be 1/3. That's what it's decreasing by. We're multiplying by 2/3 each time. That would be my common factor. In this one, we have B expanded to this. So this is still what we multiply by each time, except for it's 1 plus or minus R, where R is the growth rate as a decimal. And so like if it's decaying, then that would be negative. All right, so 1 plus or minus, depending on if it's increasing or decreasing over time. So you'll have to pay attention to those words. Like if we're spending money, we're decreasing the amount we have. Then we use 1 minus. So like, let me put these kind of near it as an example. This one more aligns with this definition. So the T power, T stands for what? So like whatever time frame we're looking at. If we're just looking at 1 month, then T is 1. If we're looking at like 10 months from now, then T is 10, right? So this goes with this setup. What we're multiplying by each time, our common factor is 2/3. This setup, if I were to use it, would be the 1800 times 1 minus 1/3. And then to the T. Both are correct. Both would get you the right answer. But depending on what it's asking for on your tests, if it says, what's the common factor? You'd say 2/3. If it said, what is it decreasing by? You'd say 1/3. But those are both going to help you, those setups. Because maybe it's hard for you to remember to subtract it or not. A lot of people will just multiply by 1/3 and say that that's what we have. It's really wrong. Questions on that? Okay, one more thing that we'll do on this back side. So I'm gonna go away from this one. So if you're still writing or you're way behind, maybe like take a picture of it or something, get it from someone else. All right, but take this other situation that's on here. We have every year after a new car is purchased, it loses 1/3 of its value. Let's say that a new car costs $18,000. So if it's losing 1/3 of its value, how much of its value is it keeping? 2/3. So instead of doing like 18,000 times 1/3, subtract that from 18,000, what I'm gonna do for just 1 year after the initial is 18,000 times 2/3, what it's keeping, to the first power, because we're only looking at 1 year for the time frame. And then you can use your calculator to do that for you, or you don't do math in your head anymore. Even if it's easy math, like this one's not that bad. All right, but after 1 year, it's worth $12,000. After 2 years, so all I would have to do is change that exponent to a 2 if I wanted to. Or I could just do 18,000 times 2/3 and then times 2/3 again. That's the same thing as putting it to the power of 2 to 2/3, but I put too big of a number at first, hold on. There we go. Right now they're the same. After 2 years, it's worth 8,000. We're doing changing the exponent or timesing it by 2/3 again. We're not timesing it by 1/3. Because that's what it's using. You multiply by what it's. Questions on that? All right, so after 3 years, I'm going to take this away. After 3 years, it is worth $5,333.33. If we're talking about money, make sure it looks like money. Like if on your homework, it's a question and it's asking how much does it cost after 3 years or how much is it worth after 3 years? Put it to 2 decimal spots. If it's talking about like a person, you can't have a decimal of a person, so then you would just stop at the decimal. And then notice in this table, it jumps to 6 years. So that's why if you were just timesing 2/3 in your calculator each time, that's why you might want to like start writing it how we write our exponential functions, where all I have to do is change the exponent rather than timing 2/3 every year. So after 6 years, this is how much it's worth. $1,580, and how many cents would that round to? 25 if we're rounding correctly. Okay, you look to the right of wherever you need to round to. If it's 0 to 4, where you're rounding to be the same. If it's 5 to 9, then you round up. All right, and then the expression for this, where t is the time, is 18,000 times 2/3 to the t. All right. So normally, like we have more time to discuss as a group, and you guys figure it out yourself. Because it's a Monday, and because there was kind of some weird stuff going on today, we're doing it this way. Hopefully, you got something out of it. You have time right now to work on your practice. You guys don't leave for about 15 minutes. You are working on your practice, 5.04 right now. And then if you're behind on stuff, then you can work on your class one. Like 5.03, you would have needed that equation in order for you to actually do it.